everyone, welcome to the new video. Today in this video, we are going to understand about ROC curve. Basically, this is one of the evaluation metric which typically stands for ROC AUC curve, which is one of the important evaluation metric when we speak about the classification problems. Like how we have accuracy, FN score, precision, recall, confusion matrix, we also have this important evaluation metric added onto that list is something called as ROC and AUC curve. Now, we all know that in a logistic regression problem or in any one of the classification problem, we are going to set something called as threshold, right? What will be the default threshold? The default threshold will be 0.5, correct? Any value which is having the continuous sigmoidal conversion value greater than 0.5, greater than or equal to 0.5, that will be categorized into the true classes. Less than the threshold value 0.5 will be categorized into the false or the negative class. That is how the model is evaluating having a fixed threshold value. But you want to evaluate the threshold like model at the different thresholds, like you have to keep the threshold as 0.7, 0.3, 0.4. How are you going to do all that? There where your next evaluation metric ROC comes into picture. What is ROC? ROC stands for receiver operator characteristics. It is one of the evaluation metric which is going to evaluate the model at different thresholds. Okay, it's going to evaluate the model at different thresholds by considering two parameters. That one is true positive rate and the other one is false positive rate. Basically, if you want to define ROC stands for receiver operator characteristic. It's one of the important evaluation metric which evaluates the model at different thresholds by considering two things. One is true positive rate and the other one is false positive rate. If you go back and recall, true positive rate is something called as sensitivity, or it's also called as recall for us, which is with this formula, true positives by true positives plus false positives. And FPR stands for false positives. That is, we are trying to evaluate how many false positives are there with the cluster of false positives and true negatives. By considering true positives and like true positive rate and false positive rate, your ROC is going to plot a curve. That is, a graph will be plotted like this by considering the two values, that is true positive rate and the false positive rate. False positive rate, you're going to draw a curve, a graphical representation will be plotted for you. It is going to give a curve something like this. Okay, that is what your ROC will give for you. ROC is going to evaluate the model by plotting a curve where it's going to take the attributes of true positives and false positive. There where ROC's work is going to end. Now your AUC will come into picture. Okay, now AUC is coming into picture. AUC is called as area under the curve. Area under which curve? It's AUC stands for area under the ROC curve. That is, ROC is going to plot a graph like this, no, by considering true positive rate and false positive rate. At evaluating at different thresholds is going to give you a graphical representation like this. Now your AUC comes into picture. What will AUC consider? AUC will consider the area down under the ROC curve. Okay, if this area is higher, then your model performance is best, like it is good. If this area is lower, your model performance is not so good, average, or it's a weak model. That is your AUC range. The range of AUC score is between 0 to 1. Okay, it's between 0 to 1, where the value nearer to 1 says the model is performing good, where the value nearer to 0 says the model performance is average. Or if you get the AUC score as 1, you can see it's a perfect ideal model. Your model performance is best. That is, your model is able to capture all the noise, all the variations in the data, and it's able to predict it on the newer data too. If it is 0.5, your value, your model is very random. Okay, it's a random model. It's not so good. So with this, we can understand AUC should always be nearer to 1, let's say 0.6, 0.7, 0.8, so that we can tell model performance is good for us. With this understanding, we'll go for implementation and see how it is implemented in Python. So for which I've taken a data set. This data set is speaking about whether the person is getting diabetes or not. I've built an entire ML model. Here we are trying to implement the ROC curve, that is from sklearn.metrics. I'm importing my ROC curve and AUC score. We all know that for evaluating any metrics, we need two things, no? Which is the actual labels and what is the model prediction. Okay, that I have stored it in whitest and white. So this is what I'm giving it to ROC curve. We all know ROC is going to give us true positive rate, false positive rate, and different thresholds. Now ROC is formed. It is giving us true positive and false positive rate. Now AUC comes into picture. AUC will take false positive rate and true positive rate and gives us the AUC score for us. You can see it's the score is nearer to 6.5. With this, what we can understand, the model performance is good. It's able to predict it with the newer data. You can visualize this also. I'm just drawing a line graph where we are giving false positive rate on the x-axis, true positive rate on the y-axis. Okay, you can see the model is like this. Whatever the gray lines is then, the gray line is with the value 0.5. Okay, that is, it's a random model. Just it's a 45-degree line which is having the visualization for you. You can see the blue line tells us the rate, tells us the AUC score of our model. So this line should be meeting our reference line here. If it is going nearer to this line without having no gaps, then with this figure, we can understand our model performance is good for us. Okay, this is how you can get an inference from the ROC curve graphical representation too. With this, we are ending the video. That is, we have, I think at the end of the video, we have got an idea of how AUC, ROC, AUC curve is helping us in evaluating the model performance. Thank you.